Okay, I'm going to have us get back to section 3.9 and we'll do some more with related rates. In a related rates problem, you're looking at how rates affect each other. So we've already done problems 1 through 3 in this worksheet here. I made a note at the end of the last video. Be careful about substituting values into a problem too early. Don't substitute anything in until you've differentiated all the variables with respect to time t. Okay, let's take a look at problem 4 next. A television camera at ground level is filming the liftoff of a space shuttle that is rising vertically according to the position equation s equal 50t squared, where s is measured in feet and t is measured in seconds. The camera is 2,000 feet from the launch pad. Find the rate of change in the angle of elevation of the camera at 10 seconds after liftoff. Okay, so I've drawn a picture here. We've got this camera, and there's a rocket that is 2,000 feet away from the launch pad that is lifting off. It's rising vertically according to the position equation s equal 50t squared. Now, we want to find the rate of change in the angle of elevation. That's going to be d theta dt at 10 seconds after liftoff. Okay, now at 10 seconds after liftoff, the rocket is going to be at a height of 5,000 feet, right? 50 times 100. ds dt would be 100t. Okay, so the position of the rocket is changing at 10 seconds. At 10 seconds, the position is changing at a rate of 1,000 feet per second. Okay, now we want to find d theta dt, like I said, at the time when t is 10 seconds and s is 5,000 feet. Now, in this picture, I have information known about the opposite side of theta and the adjacent side of theta. Okay, opposite over adjacent, that's tan theta. So I'd want to set up an equation here in terms of tan theta. Tan theta is opposite over adjacent. Opposite side is s. The adjacent side is 2,000. Now differentiate both sides with respect to time t. The derivative of tan theta with respect to time t is secant squared theta d theta dt, and then on the right, differentiating s over 2,000 with respect to time t, that'd be 1 over 2,000 ds dt. ds dt is 100t, and t is 10. Right, so you're going to have 100 times 10 over 2,000, or 1/2 would be that resulting number there on the right. Divide both sides by secant squared theta, and that way d theta dt is all alone there on the left. Okay, so t is 10. We've got 1,000 divided by 2,000 is 1/2. 1 over secant squared theta, that's the same as cosine squared theta. And so I'm looking at 1/2 cosine squared theta. Well, here's theta. Cosine theta is adjacent over hypotenuse. So the adjacent side is 2,000 feet. The hypotenuse would be the square root of the sum of the squares of the legs, right, using the Pythagorean theorem. At 10 seconds, s is 5,000 feet. Okay, so I'm taking the square root of the sum of the squares of the legs, 2,000 squared plus 5,000 squared. The square root of that would give me the hypotenuse in this triangle at 10 seconds. Now it's cosine squared theta, so make sure that you're still squaring this result there. Well, let's see here. So 2,000 squared would be 4 million. 5,000 squared is 25 million. 4 million plus 25 million would be 29 million. Now, the square root of, the square root of 29 million squared would be 29 million. And 2,000 squared, well, that'd be 4 million, but I want half of 4 million is 2 million. 2 million divided by 29 million would be 2 over 29 radians per second. Okay. Now, theta is increasing as the camera is filming the liftoff, right? The rocket is going up. So one of the things that I could know very early on in this problem is that d theta dt is going to be a positive. If I were getting a negative, that would not be good because then the rocket is heading downward. Okay, going to crash into Earth. So, pay attention to your answer, what it would look like early on, if possible, if that's going to be a positive or a negative number. Okay, and of course, make sure that the units are included. I mentioned that several times in the last video. Here's another one. Okay, problem 5. A paper cup whose axis is vertical has the shape of a cone with a height of 10 centimeters and a radius of 3 centimeters at the top. Okay, so I've drawn a picture. Here's 10 centimeters, 3 centimeters at the top. A student is using a straw to drink water from the cup at a rate of 3 cubic centimeters per second. How fast is the water level falling when the water is 5 centimeters deep? Okay, so there's water in the cup, which is also going to be in the shape of a cone. And I'll call the height of the water h, and the radius of the circular top would be r. Now, as the student is drinking water from the cup, r is changing and h is changing. Both of those are getting smaller, right? Now, what do we need to find in the problem? We want to know how fast is the water level falling when the water is 5 centimeters deep. The water level falling means that we'd like to know how h is changing with respect to time t. Okay, so we'd like to know dh dt. H is getting smaller because the student is drinking water from the cup. So dh dt is going to be a negative. That's something that I'd want to know early on, like I said. I'm going to get some negative number here in this problem. Okay, now because we're working with a cone, and the 3 cubic centimeters per second would be how the volume of the water is changing. That suggests that I'd want to be working with just the general formula for volume of a cone. The volume of any cone is V equals 1/3 pi r squared times h. Okay, now here's the thing. I wouldn't want to differentiate quite yet because I'm supposed to find dh dt. Now dv dt would be -3. I'll comment on that once we get there. But I don't know dr dt. So if I were to differentiate both sides, I'd need a product rule, and then I would be stuck because I don't know dr dt. So before we differentiate, it'd be nice to rewrite this formula so that it's all in terms of h. Okay, and I need to find dh dt. Well, in this picture, I have similar triangles. I have a right triangle within a bigger right triangle. Okay, here's a right triangle, right? And here's my bigger right triangle. Now, both of these triangles here share a common angle at the tip. Well, that's going to mean that the third angle, whatever it is going to be the same in these two triangles. So these triangles here are similar triangles. Now, whenever you have similar triangles, you have a proportion. The proportion that I'm setting up here is, r over h would be working with the smaller right triangle. Now, I'd want to match that with the radius and the height of the bigger right triangle. The radius of the cone is 3 centimeters. The height of the cone is 10 centimeters. Okay, now make sure that in a problem like this, you match the radius with the radius, the height with the height, okay, for the two different triangles there. Now, if I solve this equation for r is equal to 3h over 10, and where I see r in the formula, let's go ahead and replace that with 3h over 10. That way, everything is in terms of h. I mentioned that I don't know dr dt. Okay, so I'm trying to get everything in terms of h. I got to find dh dt. Well, if I replace r with 3h over 10 and then simplify, I'm getting 3 pi over 100 times h cubed for v. Okay, now I'm ready to differentiate both sides with respect to time t. So let's do that. We're going to have dv dt equals, on the right, we'll use the power rule, so it's going to be 9 pi over 100 times h squared dh dt. Again, make sure that you use the chain rule to finish taking the derivative. That's something that I'll see students won't have there. They won't have like a dv dt or something like that. They didn't finish the problem. Now we want to find dh dt. So let me multiply both sides by 100 and divide both sides by 9 pi h squared. That way dh dt is all alone. And now I can plug in the information that I know was given to me in this problem. H is 5. Okay, it says how fast is the water level falling when the water is 5 centimeters deep? H is 5. A student is drinking water from the cup at a rate of 3 cubic centimeters per second. Now some students would make the mistake and they would say dv dt is 3. You don't want to do that here because the volume of the water in the cup is changing, but it's getting smaller, right? The student is drinking the water from the cup using a straw. So as time goes on, there's going to be less and less volume in the cup. Therefore, dv dt would be a negative. A positive rate means that the variable is increasing. A negative rate means that the variable is decreasing. Okay, now it's important here that we indicate that dv dt is a negative, right? Because dh dt is going to be a negative, right? The height is getting smaller as the water is leaving the cup there. Let's see, if you take 100 divided by 25, that's 4. 3 over 9 is 1/3. So negative 4 over 3 pi would be the exact number. In decimal form, negative 0.424 centimeters per second. That'd be roughly what you would get if you were to round to the nearest 3 digits. Okay. Let's maybe take a look at another one here. So problem 6 says that, well, I guess maybe before we do problem 6, something just came to mind here. One of the things that you'll maybe see in the book is if a student did write 3 for dv dt, that would actually be fine if they were to give their answer using a worded statement. They would have to say that the height, or let's see, they'd have to say that the water level would be falling at a rate of 0.424 centimeters per second. The word falling would mean that you have a negative value in your answer. Okay, so to avoid any worded explanation at the end of this, I would say just make sure that you know that the answer is going to be a negative. Okay, if you were to write 0.424 centimeters per second, that would be wrong if you did not have any explanation after that. Okay, because how we would interpret that then is that there's water being filled, the cup is being filled with water. That's not happening, right? The water is leaving the cup. It's not being filled. So we would have to indicate that the water is, the water level is falling, or the height is decreasing by a rate of 0.424 centimeters per second, something along the lines of that. You'd have to say decreasing or falling to indicate that that value would be a negative. Let's actually maybe stop the video here, and I'll finish up the rest of this in the next video.